Okay, so today's webinar, we are looking at MLA Mini, the smallest and most compact version throughout the MLA series, which is the fully premium optimized multi-cellular loudspeaker array system. My name is Simon Peirce. I'm a product support engineer for Martin Audio. It's my job to do system design, computer modeling, training, webinars, any kind of technical support that anyone might need. And today, of course, I'm going to be talking to you about MLA Mini. So we're going to go through an overview. We're going to take a look at the individual loudspeakers and the components of each of the cabinets themselves, look at the rigging. We're going to have a look at the configurations of this system because it's very flexible in its design. We're going to look at cabling and network because of the inbuilt UNet structure within this system. There's some extra cables that you might not be aware of. And we're going to have a very brief look at software and control and a couple case studies very briefly, where we're just going to look at different deployments that the system has been used for. So, an overview of MLA Mini. Excuse me. So, MLA Mini is a numerically optimized ultra-compact loudspeaker system. It's not a line array. It works different to a conventional line source system because we have completely independent control of each of the components within each cabinet. So it is a line array, but it's not a line array. It's a multi-cellular loudspeaker array. It doesn't work in the same physical principles as a line source. The amplification, multi-cellular DSP, and digital networking, they're all housed within the MSX compact subwoofer. So all of the amplification, all the DSP, all of the networking, everything is within the powered subwoofer at the top. The vertical coverage can be fine-tuned electronically to cope with challenging environmental conditions. So this is when we look at our software later, when we can adjust display angles and the actual filters that go into each loudspeaker to create the vertical dispersion that we require, either mechanically or with the use of DSP. We can use hard avoid, which is completely specific to Martin Audio. No other manufacturer can produce hard avoid. This is where we actively avoid an area within a coverage zone. Exactly as it says here, just as on stage, ceilings, the site perimeters can also be programmed using our intelligent display software. So we draw the venue, and then we can tell it where the audience is, where we don't want any sound to be. MLA Mini is best suited for small to medium-sized venues, so corporate AV. It's really good for like side fills with compact. We've also used it with larger MLA systems. I've seen it used in clubs. I've seen it used in theatres. In Norway, there's even a theatre where I think even the King of Norway has sat in front of some MLA Mini. So, carrying on with the overview, an MLA Mini system comprises of 4 MLA Mini enclosures and 1 MSX subwoofer plant. So you can see in this picture here, that is 1 MLA Mini system. And you can deploy it in a massive variety of different ways, to be honest. So you can fly it underneath the MSX module. You can fly it without the MSX and have the MSX sort of pushed to one side, or even on the stage. You can ground stack it with or without the MSX, or you can pole mount it. You can fly it from a universal bracket, which we'll have a look at the rigging in a minute. It's a very, very flexible system. So let's have a look at the loudspeakers themselves. So as I said, it's an ultra compact multi-cellular loudspeaker array. It's a very fast 3-point rigging system. There are multiple deployment configurations, as we'll see in a minute. You have 100-degree horizontal dispersion of the mids and higher frequencies. Obviously, that's going to become more omnidirectional as you go down in frequency towards the subwoofer at the top there. There's a dedicated multi-channel Class D amplification in the accompanying MSX power plant, and that's actually a 9-channel amplifier. So you have 1 channel, obviously, for the subwoofer, and then for each of the 4 boxes in a single MLA Mini system, they are biamped, and therefore the other 8 channels within the subwoofer power each of the elements individually within the MLA Mini System. And the software that we use to control it is, of course, extremely accurate, tried and tested, and it's won us a lot of fantastic festival sites all over the world because it works. So as I said, it's a two-way system. That's an individual MLA Mini cabinet there. The frequency response goes all the way down to 76 Hertz, all the way up to 18K. Obviously, when you add the MSX module, I think that goes down to 50 Hertz plus or minus 6 dB. Maximum SPL is 130 dB. We use a crest factor of 6 in all of our Martin Audio products. So that means that when you've got full or peak power consumption rather than continuous, you're going to get 136 out of this system. As I said, you've got a horizontal coverage of 100 degrees, which is extremely even, to be honest. And obviously, the vertical coverage is array dependent, either mechanically or via the DSP. Each cabinet is 13.8 kilos. So having a closer look at the actual components within the MLA Mini, you've got two 6.5-inch contour diaphragm LF drivers. So as you can see, the curved kind of waveguide for the HF element there kind of curves in, and the actual diaphragms of the LF drivers curve with that, so they follow the contours of the horn wall. And that gives us a great deal of horizontal control and allows us to control the diffraction of the sound as that comes out. Looking at the HF elements, you've got three 1.4-inch neodymium compression drivers, and they're mounted within, behind that kind of that directivity waveguide. So placing several small components in such a small area of space allows us to have extended HF response. It gives us less distortion and it gives us more control. So looking at the MSX sub, this is a single 15-inch direct radiating subwoofer. So yeah, the driver is just going straight out into space. You've got a few ports around the side, obviously for air movement and efficiency. Goes down to 50 Hertz, as I said. So if you're going the MLA Mini goes down to 75, 76 Hertz with the addition of the subwoofer down to 50 Hertz. Maximum SPL is 136. So again, that's plus 6 dB with the crest factor of plus 6 dB because that's how we test and rate all of our products. And obviously omnidirectional coverage pattern. This can be configured in a cardioid array with additional cabinets, so it could be a 1-to-1 ratio, 2-to-1 ratio, however you want to deploy your system, and this weighs 58 kilos. So as I said, the MSX itself has 9 onboard power amplifiers to drive the 4 MLA Mini cabinets, which are biamp, and the MSX itself. There are 2 NLA outputs for the elegant cabling of the MLA Mini cabinets, so of course, you're going to need 8 channels to power the 4 biamp cabinets. You have onboard DSP, so obviously within ViewNet, when you've connected the MSX module, you can control the gain, ganging, EQ, delay, whatever you need to do. And there's also preset selection on the back for a range of plug and play scenarios. So there's I think there are 6 built-in presets, which we're going to go over quickly in a minute. And they will allow you to just turn up, select your preset, and crack on with the gig if you do not wish to go through the entire optimization process. And of course, there's UNet or USB connection for control using the ViewNet software. So you can actually use this in some ways like a Merlin, in the way that you can use the MSX as a bridge to go from the UNet protocol, which, as you can see below the audio inputs there on the MSX module, there are the ODU connections for connecting multiple devices together, whether that's an MLA or an MLX subwoofer. You could then convert that into USB or ViewNet protocol through the MSX sub without the use of a Merlin. Obviously, that doesn't work for larger, more complicated systems, but if you wanted to link, for example, a couple of MSXs together, you can do that with just one USB connection. So let's have a look at the rigging. And there's quite a lot of rigging available for the MLA Mini because it is such a flexible system. So you have an MLA Mini flying frame. So whenever you want to fly an MLA system, whether you want to fly the subwoofer or you just want to fly the 4 MLA Mini modules with the MSX on the ground, you use the flying frame. There's also a MSX outrigger or duck's foot, so you can use this with the MSX. It sits directly on top of it for ground stacking, and then you can place your MLA Mini on top. We've got a wind-up pole which screws into the top of the MSX, so if you want to use a pole mount or if you want to use the universal bracket. You've got a long ground stack bar. We use this with the flying frame to give us a variation of angles. For ground stacking, we have a 3-point captive rig that we'll have a look a bit more closely in a second. There's also a short ground stack bar, so depending on how you wish to deploy the MLA Mini, you either use the long or the short ground stack bar depending on the angles that you require. There's a fixed angle bracket, so this is almost for kind of more like install kind of deployment of the MLA Mini, where you don't need to be adjusting the angles on a regular basis. You can just get the fixed angle bracket, deploy it once, and that will work for you. It's a bit of an easier solution or a cheaper solution than the universal bracket. The universal bracket can be deployed this way, or you can actually deploy it upside down, so you can fly from the universal bracket, or you can place it on top of a pole with a pole mount adapter. And the angles, as you can kind of see on the bottom there, are adjustable, so depending on what your optimization file says or the preset you're using, you can aim your cabinets correctly. There's also a transition frame, so if you are flying an MSX subwoofer, you need to use the transition frame to go from the MSX subwoofer to the MLA cabinets themselves. Yeah, so, and that's only if you're actually flying the subwoofer. If you're flying the MLA Mini, then you just use a flying frame. And of course, the mechanical data modeling from display 2.3 will give you all of the angles you need. You can select whether you're ground stacking, whether you're ground stacking on a sub, whether you're flying with a sub, whether you're using a universal bracket. You can select all of these options within display for MLA Mini, and then that will of course tell you the angles and how you need to deploy your system correctly. So looking at the 3-point rig, as you can see on the back, you've got 3 pins. You've got the front rigging points and you've got the rear rigging points at the back there, and that just drops down and links to the cabinet below, so it's very quick and easy. There are various ways of rigging this system, but if you use our kind of clamshell flight cases that each of the 4 boxes comes in, you can set your angles and you can just fly all 4 at one time, just straight out the top from the frame. But some people, I've seen people do 6 or even 8 at a time, just straight off the ground, depending on how quick you want to do it and what your infrastructure is for your system, whether you're touring or doing installs. Of course, your workflow is slightly different. So you've got ergonomic handles, of course, so it's very light. As I said, it's 13 kilos. The flying frame, so this can be used for the MLA Mini or for the MSX power plant submodule. You've got 1 or 2 motor points, so you can, of course, if you're using display and you tell it you've got a 1-point lift, then it will tell you which hole you need for the correct angle. Obviously, if you've got 2 motors, then you can just adjust that using the inclinometer mount, which you can see on the side there. You can see in the middle there all of these different colored circles. So you've got the green, blue, and orange. That will dictate to you which hole you need to use depending on which ground stack bar you are using, and that will of course give you your angles that you're mounting to the bottom box. Yeah, so it's extremely versatile frames. You can see there are lots of different points to pick up from. You can fly up to 16 MLA Mini from a single one of these frames. If you are flying underneath MSX modules, then that limits you to 12 MLA Mini. You can ground stack a maximum of 8 MLA Mini, so that's with or without an MSX. So you could have two MSX modules going straight onto a duck's foot or the outrigger, then go to a flying frame, and then you can have 8 MLA Mini if you require. As I said, you've got a 1 or 2 point pickup. You've got an inclinometer for touring or production. Obviously, you don't necessarily need this if you're doing installs, because you don't need an expensive piece of equipment stuck into a frame that you only need to use once. And it weighs 17 kilos. So the transition frame, this connects MLA Mini arrays to the MSX only when flown. So you would use that flying frame to connect to your MSX, which is now flown in the air. Underneath the MSX, you'll have the transition frame. This is an integral angle adapter to reduce the top tilt of the MSX. So effectively, it's we use this to help us with our center of gravity and controlling the angle of the array as determined by display 2.3. It weighs 5.5 kilos, and it's obviously a simple piece of rigging that we use, but only when the MSX is flown above the MLA Mini. So the universal bracket, as you can see, obviously you've got the front rigging points that go into the front of the MLA Mini, and then the rear rigging point there. So it's, again, just a 3-point lift, and you can adjust the angle between 0 and 18 degrees, or minus 18 degrees I should say. And as you can see from the two pictures there, you can either fly it on top, or you can use it with a pole mount adapter below. So you can use this to fly from scaffolding, which we do quite regularly at our open days, or indeed you can use it for pole mounting, which we've done quite a few demos in the past. And it only weighs 5 kilos. As you can see, here's another view. So the front rigging bar is reversed when flown. So the front rigging bar can actually come off, and you place that relative to where you need it, depending on the angles or how you're deploying it. So again, flown from scaffolding or on a pole. The small ground stack bar will allow you to aim the array from +5 to -4. The long ground stack bar allows array aim of -6 to -20. So depending on how you wish to deploy your system, you use the bar which gives you the angle you require. And of course, display will tell you what angle you require, so you know which bar you need to use. And you can see it's all color coded. Display will tell you which hole you need to use. Very simple. You can print off a rigging report, and yeah, you can just work it straight off the list. You can see what you're doing. So let's have a look at some configurations. We of course have pole mounted there. We've got ground stacked on top of 2 MSX modules, so that is 8 MLA Mini on top of 2 MSX, and then equally we have a flown system with 2 MSX modules, and then you can see the transition frame in between there, going down to the 8 MLA Mini modules. So with the flown MLA Mini, so this is assuming that I know you've got your subs are on the ground somewhere, or maybe they're flown independently behind the PA. You can fly up to 16 cabinets without the subwoofer. If you then introduce the subwoofer, you have a maximum of 12 cabinets flown below the subwoofers, and this is all to do with the tolerance of the metal and the flying limits of the actual frame itself. But as you can see, it's quite a large array. This brings your bandwidth down from 76 Hertz all the way down to 50 Hertz. Of course, if you start adding additional MSX modules, you're going to start getting more control and a lower frequency response, because you're moving obviously more air. So ground stacking, as you can see, you can ground stack up to 8 cabinets. So that's with or without a subwoofer. Always uses the outrigger, or the duck's foot, some people call it. So you can see the MSX module sits directly onto the duck's foot. From there, we have a flying frame on top of the MSX. So not the transition frame, it's the flying frame that we use on top of the MSX that goes to the MLA Mini. You can connect up to 2 MSX, as you can see there, again with a flying frame on top, and that goes up to potentially 8 MLA Mini, or you can just use the outrigger with the addition of the flying frame directly onto the outrigger, because obviously you need that stability. And you can go straight to 8 MLA Mini ground stack like this. If you need additional low frequency reinforcement, you can actually use this in conjunction with the DSX subwoofer, which is the accompanying subwoofer for the MLA Compact. And this will bring your bandwidth down to 35 Hz. Of course, you'll still need the the MSX submodules, because you need to power the MLA Mini. You can use icon amplifiers to independently power the MLA Mini modules, and you can do this in you can upload the optimization file effectively into icon amplifiers within ViewNet with the use of display. But of course, this is quite a power hungry system, because if you think in a each block of 4 is going to need an icon 81, so in an 8-box array you're going to need 2 icon 81s, and you need every single channel. So how you wish to cable that is could potentially become more complicated. So it is simpler to use the potentially simpler to use the MSX modules, but of course that is a decision for whoever is creating or designing the system. So a minimum ratio of 2:1 for MLA Mini System to the DSX. If you are using a DSX, then you're probably going to use potentially a Merlin, or as I said, you can break out of the MSX modules via the ODU cables, and you can supply or connect network via that system, which we'll have a look at next. The DSX can also be flown, so you can see the difference. If I move back to this original picture, this is just the if you imagine a double 18-inch direct radiating subwoofer that you can place on the ground. If you wish to fly this subwoofer, you can use the addition of the flying kit, and as you can see on the sides there, now there are mounting points. So it's a 4-point lift for the DSX F, and that uses the MLA, so full MLA flying grid, because they are the same footprint. The grid, the subwoofer itself weighs 122 kilos, so I mean it's a heavy subwoofer, but then it does have DSP and the amplification built into it. Only for the DSXF, it will not power the MLA Mini. Oh, excuse me. So let's have a look at the presets. So there are 6 onboard presets which you can select from the button at the back of the amplifier. So you can see preset select on the right there. You can use this to deploy a single MLA Mini system. So an MLA Mini system, again, is an MSX with 4 MLA Mini. So as you can see, you can pole mount them, ground stack them, you can fly them or with or without a sub. Either using a flying frame or a universal bracket, and you can literally just scroll through these presets on the back with the touch of the button there. The cabling between the MSX and the MLA Mini arrays are the same for all presets, and the audio input is set to analog in all cases. So when you are using the system, if you want to use it plug and play, you can select your preset, say preset 2 for example. This will set the input to analog. If you wish to change this to AES, then you need to connect via USB, open ViewNet, connect to the MSX, and obviously change your input. So let's have another look at these presets a little bit deeper. So preset 1 optimizes the system for use with a single MLA Mini system in a pole-mounted configuration. Again, remember, it's an analog input. So this preset is appropriate for venues where there is no stage, and it assumes that the standing audience will be on the same level as the MSX. So effectively, the MSX module is not placed on a stage. It's placed at ground level where everybody's standing, and the system will cover from 2 to 12 meters from the loudspeakers. So as you can see, the color-coded cables, which we're going to have a look at in more detail in a minute, are it shows you on the actual preset. These are screenshots from the manual, so you can look at this deeper if you need to. There's obviously preset 1. You see the angle there on the universal bracket. is -14.5, and you can see the display angles, the height of the pole there. In fact, when you are using our wind-up pole, it will tell you when you have reached the preset height. So you wind the pole, and you will just see an indicator to tell you when to stop because you've reached the height for preset 1. And it's quite obvious, audience starts at 2 meters and is optimized to cover a standing audience all the way to the back of 12 meters. Preset 2 is effectively the same system, but this is designed for people who are sat down. So the ear height has changed, and this will actually extend all the way up to 17 meters for a 4-box array. So note that the tilt angle differs from that used by preset 1. So the actual downward angle of the connecting box to the universal bracket has changed from 14.5 to 17.5, and again the DSP will have changed as well as the ear height of the listener is reduced. And display is very accurate, so it is important that you make these changes, because knowing that the audience's ear height has changed by potentially a couple feet will definitely change the HF response within the given area. So preset 3 assumes that we have a standing audience and we're covering the same distance as the preset 2. Again, the angle has changed and the inter-cabinet angles have actually changed as well. Preset 4 is optimized for a ground stack array, which is mounted on a stage 1.2 meters high. So you can see the MSX is the floor is no longer at ground level; it's 1.2 meters high. It's ground stacked directly on top of the flying frame above the MSX. We're using the long ground stack bar, so we can get a downward angle of -20 degrees, and the cabinet angles have changed again. Oh, yep, so it's mounted on top of the flying frame and the long ground stacking bar. Preset 5 is when the MLA Mini is flown with the MSX subwoofer remaining on the floor. So this preset is most effective when the bottom array cabinet is 2.3 meters above floor level. So this is something that potentially you can achieve. If you cannot achieve this exact height, then of course you can always go into display, tell the software what height your array is, and this will re-optimize the angles and the FIR filters, which you could then upload into the MSX if you require. But for a 4-box system, the presets work extremely well and they can save you a lot of time if required. So the universal bracket will only support 4 MLA Mini. This is important to remember, that regardless of whether your MSX is on the floor, you can only use 4 MLA Mini suspended underneath or on top of one universal bracket. So preset 6 is used for a fully flown system. So we are using the flying frame to fly the MSX subwoofer. Of course, the transition frame below the MLA Mini, below the MSX, will then hold the 4 MLA Mini, and you can see that there are specific angles there, either inter-cabinet or the actual downward tilt. If you're using a 1-point lift, you can see it says H3, so this is hole 13. So if you have these 4 cabinets deployed under an MSX, if you use these angles, these inter-cabinet angles, this will change the center of gravity such that hole 13 will give you a -7.5 down tilt. If you've used the wrong hole, you can tell display that you've used the wrong hole and it will re-optimize if you need to. But as I said, for a 4-box system, all in all, the presets are they're pretty incredible sounding, to be honest. So let's have a look at cabling and network. So depending on the system deployment, outputs from the MSX power plant must be connected in a certain way. So depending on whether you're ground stacking or flying, you need to connect the correct boxes to the correct output, of course. And in all of the presets, they will, if you look through the manual, there will be a diagram to show you the correct way of deploying it. But the back panel of the MSX shows which MLA output feed which MLA Mini enclosures. So if we look at the orange ones, this is the first one on the left, you can see that this output feeds both the middle biamp boxes, so that's boxes 2 and 3. The green output feed the top and bottom, so 1 and 4. And each of these cables are color coded, so you can see orange and green, and they're also they also vary in length, so you can see that the longest tails will feed the upper cabinet, the shortest tails will feed the bottom. So it's very self-explanatory. So when the MSX subwoofer is positioned below the MLA Mini, the longer tails feed the upper cabinets within the pair. So as you can see, the green output there is going up to the top. The longest cable is feeding the top. The shortest cable is feeding the bottom. Obviously this makes sense because the top box is further away in space, so we need a longer cable to reach it. Oppositely, or conversely, when the MSX subwoofer is flown above the MLA Mini, the longer tail feeds the lower cabinets. So when you deploy this, either with a preset or using ViewNet, you tell ViewNet, it's just very obvious, when you connect it will pop up with a little box that will ask you how are you deploying the system, and you say I'm flying 4 boxes of MLA Mini underneath 1 MSX. Then it knows the configuration of the amplifier outputs, so you just need to cable it in this logical way. The bottom box is the furthest away from the system, and therefore you use the longest cable to reach it. In larger systems, so when larger arrays deployed, the MSX subwoofer's outputs always correspond with the MLA Mini arrays in terms of their vertical positions. So the lower box is always going to feed the lowest 4-box array. The top box is always going to feed the top 4-box array. Equally, if you have a middle box, that's going to feed the middle array. So whether the MSX are positioned above or below the array, the top subwoofer always feeds the top 4 enclosures. If the distance between the arrays and the MSX is too great for the outbreak loom, N8 barrels, so as you can see here, we've just connected some N8s. For example, if the system is flown, or if we're doing something more complicated with the subwoofers, you can also use a SockerPEX style cable if you want, but of course you're going to have to potentially get some SockerPEX to N8 breakouts or break-ins for that matter. So you can use this system to create broadside arrays, cardioid arrays. You could do N-fire if you wanted with the subwoofers. And you can obviously do all of this as long as you've got the cabling infrastructure to allow you to space your subwoofers further enough away from your arrays. So the electronics rack built into the back of the MSX subwoofer has audio input cable for accepting either standard balanced analog or AAS-free digital signal. Also featured is a paralleled connection for data chaining between devices. So if you've got 2 MSX subwoofers connected to each other, you can just link down straight into the input of the next subwoofer. Of course, when you're using presets, this assumes that your input is analog. If you wish to change this, then you must connect via the USB and open up in ViewNet, and you can change your inputs. So as with larger format systems, MLA Mini support network controlled via a UNet interface. So we can see below the analog inputs, we have the ODU connectors. These are sending out UNet connections, which we're going to have a look at kind of a basics kind of circuit diagram in a second. So all configuration data and network control traverses the system via this interface. So effectively, you are connecting all of these different modules together, and the DSP or the audio can be then linked between each of these modules. So this is the same whether you're in full format MLA or an MLX subwoofer. All of them have these ODU style connections. The only difference with the MSX is that you have kind of a mini USB break-in, whereas in a larger format system you would use a Merlin to convert the UNet information into Ethernet and then connect that to your computer. So UNet is based on a redundant RIN network and contains positional data, ensuring all cabinets receive the correct information, which is essential with MLA as it is an optimized solution. So of course you need that input or output to be fed to the correct box. As it says, it contains positional data. So this means that unlike Dante or other networking systems, UNet knows where each box is in terms of its position within a line. So if you have 10 boxes of MLA, full format MLA, it knows which boxes are in which order, and this is where UNet is a little bit cleverer, because it knows exactly where the boxes are in order, and therefore it can send the correct optimized signal to each of the boxes. So the MSX features a mini USB interface for a convenient connection to a laptop or PC. This can be used for control, to load optimization files from our display software. So the devices can still be linked using the UNet connections, as we're going to see in a minute. And a USB server such as a Silex DS5110 can be used to bridge the USB connection into a standard Ethernet network. So you can go from potentially two MSX modules, you could then put USB into the Silex and you can come out in Ethernet, and you can just attach that to a standard switch and use that as part of your Ethernet network. So you can, as you can see, we've got USB in orange there and the network in green. You can just connect your PC to the USB input, as you can see there, on one MSX, and then we can link out via the ODU connection and UNet to the next MSX, and we can control both from a single USB. You can also link back and create a redundant loop, so if one of these cables dies, you remain in control of both systems. If we're looking at a larger system, as you can see, we can connect via one USB, and we can connect all 4 MSX modules between well, in a redundant loop between each other, and as you can see, we have control of all 4. We could also use a Merlin, so we're going Ethernet into the Merlin, connecting to the Merlin. The Merlin then converts our Ethernet into UNet and sends it out to the MSX modules. This is how we would do it with a larger MLA system, but of course in larger MLA, the power amplification and the DSP is within each of the cabinets, so we need to send a UNet connection between each of the array modules as well. And of course, we can still make a redundant loop that goes all the way around, so if one of these cables breaks, we still have control of every single module. So a very brief look at software and control. These are kind of deeper topics really that we talk about in a few other webinars, which are also available on the website. So if you want to learn more about ViewNet, or if you want to learn more about display, they're kind of like their own topic in themselves. So we have our own webinars that are available that you can look at, or of course you can always get a hold of one of us if you have any trouble. So display is a proprietary software for all MLA products, and now this obviously includes all of our wavefront and O-line systems as well. Is the numerical optimization to define cabinet angles and DSP coefficients within a software, and that can be then exported or used to obviously angle your array or to upload filters into your system via ViewNet. It's a very straightforward workflow from value design to optimization output. You have 7 goals you need to achieve, and you just do them one by one, work through the system, and at the end you have an export. And the DSP coefficients for the optimized array can be loaded directly into the arrays and stored in them. So even if you turn the system off, when you turn it back on again, all of your optimization is still there. It doesn't change unless you change it. So very briefly looking at the workflow, your input is venue data. So what is the shape of my venue? I need to know a 2-dimensional vertical slice through my array's on-axis like coverage. I need to know my sound design objectives. So is my audience standing? Are they seating? Where do I need to hard avoid? Am I worried about noise on stage? I also need to know array details. So of course I need to know I'm going to fly 8 MLA Mini with 2 MSX, or I'm going to fly 16 WPC. I just need to know this information. So we choose our array type and size, we draw a venue slice, we define the audience coverage area, and criteria, so standing, seating, etc. We then optimize the mechanical array. So this tells us the angles in between the box to give us the best acoustic output for our given audience area. We can then review the mechanical information. So what hole do I need to use if I'm using a 1-point rig? What is the weight of my system? What are the angles between the cabinets? At that point, you could print off a rigging report if you required. You then optimize the array numerically. And then you can export an array preset. So the outputs are an optimized array preset, which we upload via ViewNet. You can have a look at the mechanical data, as I said, in a rigging report. You can export XGLC files, which a lot of work that I do is acoustic modeling. And we use that to calibrate the arrays within ease, because of course every single array is different because the output is defined for any given space. So every time that we create an acoustic model, we have to effectively create a brand new speaker profile for that venue. You can also export a DXF file, which is a three-dimensional wireframe, which you can look at in CAD, take measurements. You can send it to architects. A lot of installers find this useful when they're trying to converse with architects, etc. So that's display. ViewNet is our control software. So every time a system is deployed, it is optimized to suit the venue and the audience requirements. So we calculate the best possible array shape for the venue to deliver an extremely even frequency response throughout the audience. This controls the SPL across the audience, and we can also create multiple optimizations for each array to suit each audience condition. So maybe the second floor isn't used, but we can't take down the array, so we can now re-optimize to not use the second floor. Or maybe the audience starts further back or continues further back in space than we originally thought. We can change the optimization and do this. Obviously, we control all of this within ViewNet. There's no need to second guess, to be honest. All of our software, in terms of direct SPL, so it doesn't take into account acoustic data, not acoustic, like the reverberant field, if you will, but all of the direct SPL is accurate within plus or minus 1 dB, so you can definitely trust the system. Obviously, you walk around, take measurements as you always do, but after you've used the system several times, you will learn to trust it, and this really will speed up your workflow. Again, all of this is achieved within our ViewNet software. So you open ViewNet, connect to your system, upload your optimizations in each different array. You can upload various optimization files either into amplifiers in terms of WP series, or you can upload several optimizations into each MLA module or MSX, and therefore you can recall them as the day goes on. For example, if the temperature rises, you can do an optimization where humidity and maybe environmental conditions have changed. You can then recall this preset later in the day, and this will account for your HF loss due to humidity and maybe the air temperature changing above the audience. And all of this is possible within our ViewNet software. Just going to have a very quick look at some of the places we have deployed MLA Mini. So you can use it for a huge range of gigs. As you can see, this is a rock band actually called, what are they called? Haunt the Woods. This band is called a local band from the south of England. They're playing in a cave, and we've got 2 ground stacked MSX aside with a ground stacked 8-box array above them. So you can use this voiced brilliantly for rock music, and as you can see, it's a kind of medium-sized venue. The system's also been deployed at Wimbledon, so you can see we're using this for speech reinforcement and announcements across a fairly medium-sized arena there. And it's also been used for the Corona Sunset Sessions in Colombia, because this is like more of a dance sort of style DJ festival. So you can really use this system for any kind of music, for conferencing, networking events, anywhere where you need a compact multi-cellular loudspeaker array solution. This system will perform. Again, in this scenario with the dance music, maybe there are a few extra DSX subwoofers underneath the stage, or if you needed even more impact, you could obviously use MLX or the new SX H218s. to give you that extended low frequency response. But the system itself will deal with pretty much any scenario you can put it in.